Hi everyone, this is a video for lesson 5.2. I'm just going to try to make this a little bigger here. We are on page 139 in your student journal. So if you turn to 139, there's a little bit of vocabulary first, which I have already filled in, and you might want to pause the video and fill this in. But I will tell you, these same two vocabularies you had in 5.1, so hopefully you already know those. A system of linear equations is just two or more lines, and a solution of a linear equation is the coordinate point where the lines intersect. So an ordered pair that is true for each equation means the point is the same point as on both lines. So I think a picture explains that best. So here's two lines graphed on the same coordinate grid. That is a system of linear equations. The point where they intersect is the solution, okay? So in 5.1, this is exactly what we did. We graphed two lines, we found the point where they intersected. That works great some of the time, but not all of the time. It particularly doesn't work great when your solution is not whole numbers. It also doesn't work great if your solution was, say, 50, 200, because we don't want to graph something that has the coordinate point over 50 up 200. So we're going to learn some algebraic methods for solving systems of linear equations. And in 5.2, the one we're going to learn is substitution. So 5.2 is all about substitution, okay? We're still doing the same thing. We're finding this coordinate point. It's just that we're not going to have to graph it to find it. Now, the book or your journal has some steps. I have some steps written here also. Again, I'm not going to stop talking for you to write this down, so you will probably want to pause the video to write that down. But let's look at the steps they gave you. Solve one equation for one variable. This is what that looks like. You have a variable all by itself on one side of the equal sign. That's what solving for x or solving for y looks like. And on the other side, you have what I like to call stuff. You have an equation over here. You don't have a number. Well, you could have a number, but most of the time you won't. This is what solving for y looks like. Y all by itself on one side of the equal sign. When you have one of your linear equations that looks like this, substitution is going to be the best method for solving, for finding that point where they intersect. Step 2 is where they talk about doing the substitution. And step 3 is where they say, hey, the answer you got from step 2, plug it in your problem. So those steps don't make a lot of sense until we see it in action. I also have kind of rewritten the steps in a little bit friendlier language. This is not proper math terminology, though, you should know. So first thing I want you to do is to write this problem, because this is the system of equations that we are solving. So you need that here in your note section on page 139. So step 1 is get a variable alone. So this is what you're looking at. You're looking at your two equations and you're checking to see if you have either x all by itself on one side of the equal sign or y all by itself on one side of the equal sign. Now, when I look over here, this one is not solved for a single variable. But if I look at this equation, here's y all by itself on one side of the equal sign. So then I'm happy. Winner, winner, chicken dinner. Step 1 is done. I already did step 1 because it was done for me. Okay, now step 2 says substitute the stuff. So let's go back up here. This is y equals stuff, okay? So what that means is wherever there's a y, I can replace it with all of this. I want you to circle this. 2x plus 5 and y are equal. It says so right there. So that means where there's a y, I could replace it with a 2x plus 5. That is the substitute the stuff part. So in your other equation, what I want to do is where the y is, and what I want you to do up here is wrap that y up in parentheses. That's very important. And what we're going to do, I'm going to erase this, because y is the same as or equal to 2x plus 5, in this equation, where there's a y, I'm going to substitute in place of y 2x plus 5. So this is step 2, and I'm going to rewrite this equation, 3x plus y equals negative 5. But when I get to the y, I'm not going to put the y. When I get to that parenthesis, I'm going to say, ooh, I got to stop and substitute in 2x plus 5. So watch me do this, then write it. 3x plus, that's all a copy job. So I'm going to have 3x plus. Soon as I get to that parenthesis, I'm going to draw it, but I'm not going to put the y. I have decided to substitute or replace the y with 2x plus 5. That's what this arrow means. Where that y is, put 2x plus 5. So in place of the y, I'm going to put 2x plus 5, close my right parenthesis. So I've done the substitution. Don't forget the rest of this equation, though. I'm rewriting this entire equation, and I'm replacing the y with 2x plus 5. So now I have to put equals negative 5. So this is the new stuff. The 3x, the plus, the equals, the negative 5, that was all a copy job. The y is where I did my substitution. Now, if you look at this new equation, it has all x's. So when I have an equation with only a single variable, I can solve for x. So now I'm going to solve for x. So I'm going to end up at the end with x equals a number. Okay, I have some parentheses here, but there's nothing out front to distribute. So I'm going to rewrite this without the parentheses. Then I'm going to combine like terms. 3x and 2x are like terms. I like to say clean up before you start solving. So I have some cleaning up to do here. I have some like terms to combine. So 3x plus 2x is 5x. Copy the rest. Plus 5 equals negative 5. Now this is a two-step equation like we did in chapter 1 and chapter 2. Trying to solve for x, undo addition and subtraction first. Subtract 5 from both sides. That gets me 0. On the left side, I have 5x. And on the right, negative plus a negative, bigger negative. Negative 10. Still trying to get x alone. X is multiplied by 5. To undo multiplication, I'm going to divide both sides by 5. 5 divided by 5 is 1, so those 1 out. Negative divided by a positive is a negative. 10 divided by 5 is 2. So guess what? We are halfway done. Remember, our solution is a coordinate point. I just found the x value. So I'm going to go over here and say, hey, I'm halfway done with my answer. It's going to be 2, it's going to be negative 2, comma something. So this is half of my answer. Now, if I know x, I can go back to my original equation and I can replace or substitute negative 2 in for x in either of these equations and then solve for y. So I know x is negative 2, so I want to plug negative 2 either into this equation or this equation to solve for y. Remember, I need an x and a y. Now, I can tell you, doesn't matter which one you substitute it into, but why not substitute into this one? Because this has already got y by itself. So once I put my x equals negative 2 in here, do some cleanup over here, I'll know what y is. So we did step 3, we solved for x equals. Step 4 says plug in what you solved for. So x equals -2, I'm going to substitute or plug in right here. So this was step 3, and now I'm about to do step 4. So I'm going to copy that equation first, y equals 2x plus 5. And I'm going to replace the 2, I'm going to replace the x with a -2. So I'm going to have y equals 2 instead of 2 times x, 2 parenthesis -2, because x is equal to -2 plus 5. That's a copy job. Okay, let's simplify this. Y equals 2 times -2 is -4 plus 5. Y equals -4 plus 1. Adding and subtracting of one positive, one negative. I'm going to subtract. 4 minus 5 is 1. More positives than negatives, so that's positive 1. So there's the other part of my coordinate point. So the solution is -2, 1. If you went back and graphed these, like we did here, the point where they would intersect would be -2, 1. Okay, I want you to now turn to page, I think it's on the back here, yeah, 140. Let's do a couple more here. 140, I'm going to start with number 1. You'll notice I already have the answer there. Okay, let's see how we got it. And I will remind you of the steps. So the first step, actually, let me show you. The first step said get a variable alone. So you want to check to see if you already have that. And if you don't, we need to do it. But if I look at this one, I notice I have y all by itself on one side of the equal sign. So it is already solved for y. So that means y equals 5 plus x. So in the other equation, where there is a y, I can substitute in 5 plus x. Because y and 5 plus x are exactly the same. That's what equal means. So in this equation, I'm going to copy it. 2x plus 2 parenthesis. That's why I want you to put those parentheses there. Replace the y with a 5 plus x, and then keep copying that equation. So let's rewrite this equation. 2x and plus, that's all a copy job. 2, don't forget that 2, parenthesis, substitute in 5 plus x for the y. That's why it's called substitution. Right parenthesis equals 10. Do not skip this parenthesis step. You can see right here, when I have 2 outside parentheses, that's distributive property. If I didn't have that parenthesis there, I would think that was 25, and that would not be right. So don't skip these parentheses. Now we have an equation with all x's, so we can solve for x. Order of operations says do parentheses first, so we're going to do the distributive property here first. So I'm just going to copy the 2x and the plus. 2 times 5 is 10. 2 times x is 2x. Everything's positive, makes it nice, equals 10. Now I see some like terms on the left side of the equal sign. 2x and 2x are like terms, so I'm going to combine those. 2x plus 2x is 4x plus 10 equals 10. Keep going. I want x alone. Subtract 10 from both sides. 10 minus 10 is 0. On the left side, I have 4x equals 10 minus 10 is 0. Don't panic. That's fine. 0 is a number on the number line. It's okay that we get a 0 here. Keep going. To undo 4 multiplied by x, divide both sides by 4. 4 divided by 4 is 1, so those 1 out, and I have x equals 0 divided by 4, also fine. put it in your calculator, you will get 0. So x equals 0. That's what I had up here. 0 is x. So go ahead and write that up there. Now we have to find y. So I'm halfway done here. But I know x is 0. It's really nice when x is 0 because 0 is an easy number to plug in. Now, yeah, I have to go back to my original equation. I can either put 0 in here or 0 in here. But I'm trying to find y, and this equation is already solved for y because y is alone. So I'm going to copy the second equation, and I'm going to replace the x with 0 because x equals 0. So I'm going to copy the y equals 5 and the plus, but instead of x, I'm going to put a 0 in there. Well, what's 5 plus 0? That's just 5. So y equals 5. So my solution is x is 0, y is 5. There's a lot of algebra going on in these problems. You need to be very, very neat when you are solving these, or you're never going to be able to find your mistakes or follow your work. So as neat as I'm being, you need to be. All right, let's look at another one. Let's look at 5. Again, I'm telling you what the answer is. All right, so step 1, do I have a variable all by itself on one side of the equal sign? Yes, I do. It's okay that it's an x. The first 2 examples we did, it was a y, but it's okay that it's an x. If x is all alone on one side of the equal sign, that is fine. It can be x equals or y equals. So x equals all this stuff. So in my other equation, I'm going to substitute in all this stuff where the x is. Put those parentheses. So now we're going to recopy this equation. 2 parenthesis 3x or 3y plus 5, right parenthesis, plus y equals 3. So let's copy this. 2. When you get to the parentheses, put on the brakes and remind yourself, I'm not going to write that x. You're going to follow your arrow here and write the 3y plus 5. I want you to use all of these little tricks I'm showing you here. Then right parenthesis, then copy the rest of the problem. Plus y equals 3. After you do your substitution, you should have an equation with only one variable. You can see this is all y's. So now I'm going to be able to solve this and get y equals a number. I see some parentheses and I see distributive property happening here. So that's what you want to do first. Order of operations has parentheses first. So 2 times 3y is 6y. 2 times 5 is 10, and they're both positive, so it's plus 10. So I did my distributive property here. Now the rest is a copy job. Oops, equals 3. Got some like terms again on the left side of the equal sign, so combine your like terms. 6y plus y, 7y, plus 10, don't forget about that, equals 3. Okay, still trying to get y by itself. 10 is furthest from the y, not touching it, so subtract 10 from both sides first. That's 0. So on the left side of the equal sign, I have 7y equals 1 positive, 1 negative, so I subtract 10 minus 3 is 7. I have more negatives than positives, so my answer is negative. 7y equals negative 7. Now 7 multiplied by y, to undo multiplication, I divide both sides by 7, not negative 7, 7. 7 divided by 7 is 1, so there we go, y is all by itself. Negative 7 divided by positive 7 is negative 1. I am halfway done. And you can see there's my y, negative 1. Now we have to find x, which is 2. So let's go back to our original equations. And this one right here, x equals 3y plus 5. Well, x is already alone, and that's what I'm trying to find. I already have y. I need x. So I'm going to substitute -1 into this equation. So y equals -1. I'm just copying that from here. I'm going to put this -1 right in here where y is. So x equals 3. When I get to the parentheses, don't write the y. Substitute the -1, right parenthesis, plus 5. Keep simplifying. X equals 3 times -1 is -3, plus 5. X equals -3 plus 5 is +2. So x equals 2, y equals -1. Okay? I want you to try this one. Write the answer. This is what you should get when you are done. Okay? You might have to do your work over here. We kind of used up that space. Now, I just want to start number 10 with you on page 141. So turn the page to page 141. And I want to look at 10 because if you look at 10, you'll notice it doesn't have that step 1 done for us, this step where x or y are by themselves. So this is the first time we actually have to do step 1, where we have to get x or y by themselves. So when you look at these equations and you say, x and y are not by themselves, I need to do that. There's an easy one to get by itself. And what I want you to look for is what I like to call the naked variable. So for example, x and y I call naked variables. And the reason I call them naked variables is because you can't see a coefficient in front of them. There is a coefficient in front of them. There's a 1 here and a 1 here. But if you compare it to this, see this 2x, that's not a naked variable because I can see the 2. If you see this 4y, that's not a naked variable because I can see the 4. So if you have an equation with a naked variable, that's the one you want to do step 1 to first. So step 1, I'm going to rewrite that equation. And I want to get either x by itself or y by itself. Well, in this case, it doesn't matter. They're both naked variables. So I'm going to say, well, I think I'm going to get x by itself. So what I want, what I'm shooting for is, I'll show you up here, I want x equal to stuff. I want x all by itself on one side of the equal sign. So if you look here, here's my equal sign. I have x and I have plus y hanging out over here on this side of the equal sign with the x. So I want to get rid of that y. So let's minus y from both sides because positive y and negative y make a 0. So that adds to 0, and I would have x left on the left side of the equal sign. And over here, those are not like terms, so don't add them together, but I can just do 3 minus y. And now step 1 is done. Y is all by itself. Now here's another little thing you have to be careful for. So this is when we can do our substitution. X is equal to stuff. So I want to substitute my stuff up here. We already messed with this equation. So we cannot substitute back into the equation we already messed with. We have to substitute into the other equation. So in the other equation, we want to put parentheses around the x, wrap up the x, because we are replacing x with 3 minus y. And then let's do our little arrow here. So now this equation is going to become 2 parentheses, let me scooch over here, 3 minus y, because I am substituting in 3 minus y where the x is. Then keep copying. Plus 4y equals 8. This equation has all y's, so we can solve for y. So distributive property happening again. Do that first. 2 times 3 is 6. 2 times negative y is negative 2y. Copy job. Over here on the left side of the equal sign, do some cleanup. Combine like terms before you start solving. Watch your negatives on this one. 6, negative 2y, and positive 4y is positive 2y. 4 minus 2 is 2. Equals 8. Okay, we want y by itself, minus 6 from both sides. 2y equals 8 minus 6 is 2. Divide both sides by 2. Y equals 1. Kind of running out of room here. And if you look back up here, that was what we had, y equals 1. I'm not going to finish this one in this video. You can actually finish it. Once you have y, go back to one of your original equations, doesn't matter which, and substitute y equals 1. I would substitute it into this equation because it just looks like a nicer, simpler equation to work with. So you're going to substitute 1 where the y is and then solve for x. Okay, I'm going to stop here, and in the next video I'm going to do this word problem.